You find the item you want, enter your details, and click Buy. In a fraction of a second, that single keystroke launches a cascading chain reaction of data across the globe. This diagram shows the original World Wide Web architecture. A browser requested a specific document, and a single server sent it back. It was a closed loop. The server returned the file and immediately forgot the user, a stateless exchange. Modern e-commerce breaks that simple model. Hitting that purchase button simultaneously pings the retailer's internal inventory database to reserve the item, contacts an external banking network to authorize your credit card, and alerts a third-party shipping courier to generate a tracking number. These separate systems are usually owned by different corporations. They are housed in data centers on different continents, and they operate using entirely different software and programming languages. How do completely alien machines, built by different people, instantly negotiate a secure financial exchange without a single human stepping in to translate? Web services provide the standardized architectural layer that transformed the internet from a passive document library into an automated computing engine. The millisecond after you finalize a purchase, the storefront server hits its first roadblock. It needs a bank to process the payment, but it has to actually find one that can handle the specific request. A server cannot use a human search engine to browse for partners. It requires a rigidly structured, machine-readable directory. This is where a protocol called UDDI steps in. Standing for Universal Description, Discovery, and Integration, it functions as an automated directory service built exclusively for machines. The retail server sends a query to the UDDI database detailing the exact financial service needed. The directory filters its records and returns the precise network address of a banking server capable of fulfilling that request. Without this standardized registry, servers would have no reliable way to discover external resources on the fly, making dynamic machine-to-machine partnerships impossible to maintain. Finding the bank is only the first step. The storefront server now has to know the exact data format the bank expects before it can transmit your credit card details. This requires the Web Services Definition Language, or WSDL. It acts as a strict, formal rulebook, what engineers call an interface definition language. It explicitly lists the exact function names and data types the bank server will accept. This flowchart illustrates how the interface definition generates communication code. The top interface file provides syntax rules. Passed through a compiler, it generates client and server stubs. These custom translators perfectly package data on the sender's end and unpackage it on the receiver's. With a shared blueprint, two completely different operating systems can instantly construct perfectly matching software components to exchange data. Now that the two machines are speaking the same dialect, the actual transaction begins. The data is transported via the Simple Object Access Protocol, or SOAP, and formatted using XML. XML presents an engineering trade-off. It requires layers of nested text tags for simple data points, making files massive to parse. Yet because every point describes itself, any server can read it. To protect this financial data across the open internet, the XML payload is wrapped in a secure transport layer security channel and branded with a digital signature to ensure it hasn't been modified. Even after the bank clears the funds, the storefront must still confirm the order with a third-party shipping courier. If the bank approves the charge, but the shipping server goes offline 3 milliseconds later, the system faces a partial failure. You have paid for an item that will never be dispatched. To solve this, developers use strict coordination protocols, such as a two-phase commit. This system acts as an overarching manager, actively monitoring every single node involved in the transaction sequence. By requiring every participating server to confirm its state before making permanent changes, these protocols ensure the entire web service acts as a single entity. If one server reports an error, the entire transaction instantly rolls back to prevent data corruption. Automated discovery, interface definition, secure transmission, and multi-node coordination. All of this intense computational negotiation happens in the handful of milliseconds between clicking your mouse and the confirmation screen loading. This shift moved the internet's primary user base from humans to autonomous machines. Modern software is no longer built as a single, monolithic application. Instead, it relies on service composition. Developers now assemble applications by integrating specialized existing web services into a single cohesive workflow. One service handles the payment, another handles the location tracking, and a third handles the inventory. The modern digital world is defined by this invisible, standardized framework of machine-to-machine trust that binds millions of isolated servers together.